Okay, so let's start the programming session. So this is the first comprehensive introductory session on using Jupyter notebooks in developing programs for quantum computers. In today's session, I will introduce the basics of NumPy, and I will also introduce Qiskit, which is the main package for quantum information science and quantum computer programming from IBM. And we will almost cover all the gates that we discussed in the last lecture. For example, the X, Y, Z gate and Hadamard gate, how you can, what are the commands and codes to implement them in Python. And we will sort of begin building quantum computing circuits or algorithms, as some people like to call them. And hopefully this would be slow enough that you can all follow along. So to make it, easier and at a slower pace, today I will try to, write all the code myself. Though in later lab sessions, when we are a bit fast, I will have pre-prepared the notebooks and I will just, simply explaining and running them in front of you. Okay, so let me start sharing my screen. And let's begin. Let's go to Jupyter. Okay, and you can start new file by clicking new here. Select Python 3 because this is a version 3 that we are using, and you will be, guided to this part. You're able to see my cursor moving, right?
Yes, sir.
Okay, perfect. Okay, so as I explained last time that Python works by, in the form of different packages. There is some basic functionality available without importing any package, but most of the functions and programming tools, they're available as part of different packages. For example, let's start by importing NumPy package, and we can abbreviate it as NP. And you don't have to abbreviate NP. You can abbreviate any, favorite name like you want. Like you can have NY or you can have PY or something like this. But NP is one of the most famous abbreviation for this that most people do. So let's choose that. You only have to import it once in your whole session before you either quit kernel or you restart it. So for example, we can define complex numbers using letter J, but if you just want to write iota, then J will not work. Even if you want to write iota, you will have to write a number alongside it, like 1J. So that is actually iota. Let's say I press enter and then B is equal to some 2 minus 3J, and I can compute, suppose the normalization constant, if I want to make this A, B as the coefficients of my state ket. So let's say we have NP square root and absolute of A square. The power is represented by 2 stars plus absolute value of B square. And now let's say I can have a state vector, some state 1. Let's say I can write it as a vector like this: A divided by norm, B divided by norm. So I can print this state 1 by writing print command. So you can see that there's first complex number, second complex number, and I have normalized them by this norm. So it will have a magnitude of 1. Okay, so let me describe one important functionality in Python, and that is when you have to write loops. So for example, you want to write a loop, say 1 to 10 or something like that. So the syntax for that is for I in range, let's say 10. So this actually means that I goes from 0 to 9. So by default, Python starts indexing from 0. And when we specify something, some index, it goes to the extreme -1. And you put a colon at the end. And there's already, a tab pressed here when I pressed enter after this colon. Because in Python, you make blocks of codes by using the tab space. Okay. In some languages, for example, C, you specify the beginning of a block of code by, let's say, begin and end. So for example, in MATLAB, you specify the beginning using for, if, etc., but you specify the end of the code by writing end. But in Python, you don't have any of that thing. You specify the code block using the tab space. If the code block is one tab, for example, in front of this, so it means that this is part of this for loop. If you simply, let me just write it something like print I. So I do this thing, and now I press enter, it is still there. But if I press space and I do something like this, print 10 here. So now this last print 10 is out of this for loop. Same because it is present at the same level as the for itself. So it's not part of the for loop. So I specify the end of this part of the code under for loop by going back to the same level of indentation as for the for loop. So if I execute it, you see I print 0 to 9, and let's say, let me make it something 100 to make it different. So you see the for loop went from 0 to 9 because I goes from 0 to 9. You can start, give a different range, 3 to 10. Okay, so 3. So now it goes from 3 to 9 with a comma. You can specify the number of times. Similarly, there are other ways. If we have some vector element, for example, an array or a string, we can write a for loop to jump through that as well. For example, if I have some bit string, let's specify it 0, 1, 3, 1, 0, 1, 2, something like this. Then I can write a for loop, and I say that you step over this bit string. So now my I is going through this bstr variable, which is nothing but this 0, 1, 2, 0, 3. And let's just see what is coming in I. So I say print I, and I can do something like this, print I don't know, something from I something. So now you see that at each step of the loop, it's printing I, but it's also printing, if I eliminate this one. So this I variable went from 0 to all the way 3, 0, 1, 2, 3, 0, 0, 2, 3. So all of these variables have been printed. But if you print it, try to print it like this, that I have a range. So there are 1, 2, 3, 4, 5, 6 elements. So I write 6, and then I print bstr I, and I'm able to print it again because now my I goes from you see I goes from 0 to 5. So indexing in Python happens like this, that the first element is index 0, then 1, 2, 3, all the way wherever you go. So that's why Python has this thing in variables as well, that when I specify the range to 6, it only goes to 5 because indexing starts from 0 in these vector elements like this bit string. So you can write for loops like this. Is there any question? Let's say I write another loop now using only a bit string of 0 and 1 0, and suppose I write a for loop for I in BSTR, but I say if statement can be written like if I is equal to, let's say, 0. Remember to put colon when you are writing this if or for statements. I say if I is 0, print 0. Now when I pressed enter, it took the cursor right under print, but if I press backspace, I can get out of this block of code of if, and now I'm back to writing code for loop. So again, I'm saying if I is, let's say, equal to 1, then print 1. Okay, so there is some trouble, but
line 6 में colon ही डाला हुआ.
Oh yes, thank you. Now you see that when my variable I goes through this vector variable BSTR, when it is 0, it prints 0. When it is 1, it prints 1. So I'm just giving this as an example of writing for and if statements in Python. All right, so you can write along with me in your own Jupyter notebook if you want, and I will also share this notebook with you at the end of this lecture. So let's say I want to write some matrices, so I can write some identity matrix like by calling this command identity from Python. So minus cannot come in the name, underscore can come in. So you want to print out this thing, so print I matrix. So you see this identity matrix is available here. I can access the elements of this matrix. Let's say I want to change the element 0 0. So 0 0 element is this first element. Okay, so even in these rows and columns, indexing starts from 0, so it goes 0 1 2 3. So in this 3 by 3 matrix, this first element is 0 0, the second 0 1, then 0 2, then this one is 0 1 1 1 1 and 1 2, and so on. So this 0 0 element is this one, and let's say I make it 2, and this indexing.
दूसरा आपने मैट्रिक्स के अंदर ए नहीं लिखा.
Thank you. I'm glad that you people are paying attention. So
I don't think कि आपको print भी लिखने की इसमें जरूरत होती है. अगर आपसे वो उसका वो variable लिखेंगे तो it will print like Jupyter notebook के अंदर I think.
नहीं, लेकिन अगर मैं ये last print command नहीं लिखता, let's say I comment it out, then वो sign तो कर देगा, but this print is executed over here before this I matrix is changed.
नहीं, मैं कह रहा हूँ कि अगर आप सिर्फ I underscore matrix पे लिखते ना तो it will print it without the print statement.
जी जी बिल्कुल बिल्कुल, you are absolutely right. So if I just write it I matrix, it will print. Okay, so even if I don't write print, it will print, but I'm sort of in habit of writing this print. Okay, so and I think there's another trouble with that, because if I don't write print and I just write variable, then it only prints the last one, not the previous ones.
Oh, okay.
Yeah, so if you want to print out multiple things, then you have to specify the print. And you can check, for example, if I write I matrix here, let's eliminate the first, sorry, it's 3. So you see it only works on the previous method, eliminated the print from the first command. So specifying print has this making sure that it will print that thing irrespective of other prints. Okay, so similarly, as I was able to loop through a bit string, I can, loop through some array. For example, if I have an array like 3 minus 2, 10, 3, 7, and so on, then I can write a for loop for I in AA, and let's say print I. So now you see this for loop actually worked and looped through this array, and you don't have to always loop through the index that you specify I from 0 to whatever number, and then you access individual element of array like this. So you can do indexing, looping right through the elements of the loops, or you can loop through it like this: I in range 1, 2, 3, 4, 5, and then you print AA of I like this. So you can loop through the array like this, that through the index as well, but then you will have to access the elements of array using this AA square bracket I. So actually, we wouldn't be needing too much programming skills from Python. Most of the time, we would simply be needing loops, sometime decision statement like if, else, etc., and occasionally matrices, and that's all. Even though programming in Python is very rich, and there are a lot of syntactic sugar available to do many things, to do the same things in many different ways. But fortunately, we won't be needing that. Most of the time, we will actually be needing this package Qiskit. And those of you who who are going to use Qiskit for the first time, they might have to install it if it's not already part of the installation package. And you can install this package by writing this command, pip install Qiskit. And I have already installed, but let me just run it in front of you so you can see. So you see that requirement already satisfied, etc. So it's installing these packages. But once this installation is done, you don't have to do it again and again when you use it later. Even if you have closed your kernel and you're coming back, it's installed one, it's done. But each time before you use it, you will have to import this Qiskit. And instead of importing it fully, we might need some parts from it. So let's say from this Qiskit, there is a visualization package, and from that, let me import plot block multi-vector. So I'm going to use this plot block multi-vector.
I think इधर दूसरा import job में लिखा इधर as होना चाहिए. I think शायद visualization पहले इसको पढ़ा होगा.
I'm just checking visualization import. Plot block multivector visualiza.
Sir, import is written to.
सही ऐसा हो जाएगा कि import plot block multi-vector from Qiskit.visualization.
Let me import something else, and then, oh, sorry, I had to write from here. From this package, I'm importing this part. Okay, so now I have this block multi-vector imported, and I want to show you its use. It's the same block sphere that we were talking about. So let's say I have some state 0, 1. So some state equal to 0, 1, and let me plot it block multi-vector sum, and you do understand that this is the 0 cut sorry, this is 1 cat because this is 0, 1. And you see that this is the block vector pointing right towards the 1 state. So you can, use this block sphere in the Qiskit package by using this plot block multivector command. We already had some state defined in the beginning. What was its name? State 1. So let's see what this state 1 plots to in there. So plot block multivector state 1. Okay, so this is almost along, x-axis, because it's 0.25, 0.25. So this just turns out to be along there. But let's make it, little bit different to see if it changes there. Yeah, you see now it's changing. So whatever state you specify, you can visualize it on the block sphere. All right. So if you want to, describe your states in a way that we were talking about in the lecture notes, where we had states written like some A times 0 states and some B times, the 1 state. So for that things, I can define these A naught and B naught numbers. So these A naught and B naught are simply 2 states that corresponds to your 0 and 1 cat. Well, actually, let me write it cat 0, and let me write it as cat 1. This would be even better. So I now define these 2 states. So let's specify some other numbers. For example, I can have some state CS as cat 0 plus some iota 1j star cat 1. And now I can normalize it by computing magnitude NP square root and absolute value of the first element square plus absolute value of the second element, and you see indexing happening from 0 square 2. So this is mag. So this state 2 is CS divided by mag. Now this is my normalized. Let me put everything, at one place. And now we can plot block multivector state 2. Now this is 0 plus iota 1 state, and you see this is that iota state that you are seeing right here. So if I make it like the plus state, which was just 0 plus 1, and the 1 over square root 2 is being taken care of by this mag part. And you see this is this plus state, and if I put the minus sign here, this is that minus state going backward, and so on. And I can have, let's say, 2 here, so 2 star, and 3j star, and this is some source. So whatever state you want, you can visualize it on the block sphere like this. Now let's see how you can implement quantum gates. For that, let's import quantum circuit from Qiskit. From Qiskit, import quantum circuit. Remember, Python is a case sensitive language, so you can't write this small q and small c. And let me define your first quantum circuit as quantum circuit with only one qubit. So this is how you define quantum circuit QC as this. Now let's implement a Hadamard gate. Since Python fundamentally is an object-oriented language, which means you can create objects, but then when you have to do any operation on that object, you always have to refer to that object. So this QC is a quantum circuit. Now this is an instant of that, this class quantum circuit that I have called over here. Okay, so if I want to apply a Hadamard gate to this QC object, so I just write H, and then I have to specify the qubit. Now remember, this quantum circuit that I'm calling has only one qubit because I specified one here. So that first qubit is indexed from 0. So I specify the index 0. Now you can also, draw this quantum circuit and like this. But if you want to have, a better drawing of this quantum circuit, always use matplotlib, this, option in the draw part. So the circuit is a little bit better. Now you see, I'm just executing it, keep on adding the Hadamard because each time I execute this, block 48, a Hadamard is added. But if you want to make sure that more execution doesn't change the circuit, put it in the same part where you first initialize the quantum circuit. So it's like this. So it's always like this. If you want to have 2 qubits in the circuit, you can have 2 qubits. And now this Hadamard is only on the first qubit. I can, let's say, apply an X gate to my second qubit. And you see there's an X gate over there. If you want to, after the, Hadamard to the first gate, you want to apply I don't know, some Z gate to your 0th qubit, you can apply it right there. So Hadamard Z X right there. So this is how we actually define quantum circuits and express quantum gates. So any question? Okay, so
सर
if I
कुछ
give,
ऑप्शंस चल नहीं रहे हमारे।
कौन सा वाला नहीं चल रहा?
सर ये जो QC H और आपने ड्रॉ किया है ना, वो ड्रॉ नहीं हो रहा मेरा।
Did you use qc.draw and this MPL in these apostrophes?
Yes sir.
Okay, and does it work without MPL?
No sir.
So because MPL comes from matplotlib, so if it doesn't work even without that, so does everything else works other than this qc.draw?
Yes sir, बाकी सब चल रहा है।
Okay, so I am not sure exactly what is the problem, because if there was a problem with MPL, then I could have guessed that your matplotlib library is not properly installed. Okay, so I'll have to, debug your problem. Is everybody else able to run?
No, sir, the same problem.
So what is it that you're not able to run? This draw command?
Yes, sir.
So everybody is having this problem with the executing qc.draw? Okay, so some people might have, an earlier version. And if there's a trouble, you might want to, use colab.google.com. They usually have latest packages. And if the troubles remain on your install directory, the best option I would say is uninstall everything related to Python and then install the newest version that is available on their website.
जी सर मेरा QC ड्रॉ चल गया है, MP1 नहीं चल रहा।
MP1 नहीं है, MPL है। It's MPL.
MPL. Thank you. Sure.
Matplotlib library. It's coming from Matplotlib library because the whole plotting thing goes on behind it when we use that. Okay, it's working now.
हाँ मेरे लिए कर रहे हैं सर.
Good. So the last thing that I want to discuss today with this circuit is this, that if I specify you an input state and I ask you that, okay, there are a bunch of these gates, tell me the output. You can do it on paper by multiplying those matrices with the input state again and again, and then at the end you will have some result. But you can do the same thing in Qiskit as well. Okay, so let me show how. So let's go back to this single qubit circuit for now. Okay, so I am having some. All right, and then let's say I have some state 2, and I want to evolve the state 2 from the input to the output. That I want to see that if I give this state 2 as an input, what state would be the output state. So for that, we can import from Qiskit quantum info package. Let's import state vector, and let's see what new state is. If I evolve my state 2 under this circuit QC, and let me plot block multi-vector new state. Okay, so I might be missing one package. That evolves state vector. State 2 is here. Is this? Let me see, I have it over here, state vector. It should be able to evolve general state, but let me make the state from using a label state. So some state SV has state vector from label. So let's evolve this SV state. Okay, so this state that is given here, this might have to be expressed in a certain way. Anyway, for that, let's say if I print this SV state, print SV, and what is print new state, Okay, so it has to be represented in a state vector, not an array. Anyway, so this state 0, when you apply this Hadamard and Z gate, it goes, you know, from this 0 state to the other side. So if I just want to see the action of Hadamard, let's eliminate the Hadamard. This is the Z gate, so this is Hadamard. So under Hadamard gate, you see the 0 state coming towards the plus side. Similarly, if you want to see the action of X gate on the 0 state, and you see the 0 state is after X gate, it's going towards the 1 state, that it's becoming the knot of the 0 state. Okay, so I hope that this gives you an idea of how we implement quantum gates in using Qiskit, and we'll build upon these you know, basic ideas in the coming lectures.